I talk an awful lot about humanoid robots. They're super cool. They walk, they kind of look like us, but are they distracting us from potentially the most important things in robotics? In other words, are we criminally underinvesting in robotic hands? Hello and welcome to TechFirst. My name is John Koetsier. My guest today says that $50 trillion in economic activity globally flows through hands. That's opposed to 15 trillion through navigation and transportation. However, robotic manipulation companies, hands companies, have raised only $2 to $3 billion, while tens of billions of dollars flows into transportation, and tens more flow into walking humanoid robots. Sanctuary AI CEO Jordi Rose once told me that half the complexity of making a humanoid robot is actually in the hands, and almost all the jobs we want robots to do require hands, complex and delicate manipulation of things in our environments. So what's the solution? To chat, we have Mike Obolonsky. He's a partner at Cortical Ventures and has a long history in AI and robotics. Welcome, Mike.
Pleasure to be here, John.
Pleasure to be with you. Tell me about hands.
Yeah, so, human evolution, I think everything around us, like literally like everything around us, is been built by hands and for hands. It's every object that we touch, every man-made object that we touch is probably was built assuming that humans have, this like amazing dexterity, that humans have amazing proprioception, amazing sense of touch. Whenever we design like a new kind of hardware object, like people who are designing the object, they kind of like assume this as kind of like a given. But when it comes for robotics, that's becoming like one of the hardest thing to achieve, to build AI for. And if we will talk probably a bit more about this for humanoids, but this is one of the hardest things in robotics at the moment.
Hands are really hard, right? I mean, hands are quite amazing. They're self-repairing, which is incredible. Human hands, right? They're strong. They can swing a sledgehammer. They're delicate, amazing sensitivity. They can hold an egg without cracking it or crack just the shell of the egg without smashing it, right? We can hold a glass of water, even in a very delicate wine glass, right? Without smashing it. And yet we can grip things and lift, 500 pounds, 1,000 pounds or something like that. Some of us, not all of
I
us.
think what you're saying is basically like, you can think of like two, like on the spectrum of things, like there are two things, right? On the one hand, you can have like a surgeon performing like a very like sub-millimeter accuracy motion using a tool. And like, so it's not just like the hand, it's also like a tip of the tool. So I had this like fascinating discussion with one of the like researchers, and he basically explained to me, when we have like, for example, I have a screwdriver here. So when I touch this tip of a screwdriver, I actually feel the vibration in my fingers here.
Yes.
So we have like a very special sensors here that
Feedback.
define like how we sense how we measure the force at the tip of the tool.
Yeah.
Robotics have like none of that. And that's kind of like on the spectrum of like being precise, but also like on the other side of the spectrum is like just being like bulk and gross and applying a lot of force. Think about a hammer. Like we hold a hammer and then when driving a nail, and we can do it with enormous amount of force and with a high precision. I mean, like with like certain like accuracy there is obviously like much smaller
Yes.
than with fine-grained manipulations, but like human hands are covering this this enormous spectrum of things that we can do.
Can we ever hope to get robotic hands that approach that flexibility and capability?
I hope so.
Such faith. It is hard. It is really challenging, right? I mean, they need to be loaded with sensors as you just talked about, right? It's really, really challenging. Okay, we'll come back to that. We'll come back to what they're important for, what we need them for, what we'll use them for, what breakthroughs we need to make, and what ones maybe we have made. Let's talk about the funding, right? You in the pre-show as we were chatting and the information your team gave me, so much funding to humanoids, so much funding to autonomy cars, self-driving cars, Waymo, other things like that, right? So little funding to this. Why?
I mean, I think let's probably distinguish. Like there is a funding that went towards or is going towards the autonomous driving.
Yep.
Well, let's put it like so. For me, like I split kind of like the whole kind of robotics sector into navigation and autonomous navigation tasks, right? And then you can split it further into kind of like on-road, off-road, and
Mm-hmm.
manipulation. And then manipulation can be like general purpose manipulation or like task specific manipulation, where you just like
Mm-hmm.
need to basically hard code the trajectories and like a very specific end effector. So let's probably like talk about like first autonomous driving, which is like a navigation subset. Companies like Waymo and all these autonomous driving companies in the past, they were
Mm-hmm.
going after like a relatively small market compared to manipulation.
Mm-hmm.
But
Mm-hmm.
my understanding and kind of like like with the benefit of insight here a little bit, um, the value prop there was much clearer, and like in the
Mm-hmm.
tech stack was way better developed. Like we
Mm-hmm.
had cars for many years now.
Mm-hmm.
It was not a sophisticated tool. It was like four wheels. They were going like in a fairly structured environment off the
Yes.
road as compared to, for example, off-road navigation, which is not so. And then, the value prop, like the business case for the investment, it was able, like people were able to make like much more clear.
Mm-hmm.
So, and in absolute numbers of just like pure dollars, like the economic use case is, probably worth the investment. Humanoids, on the other hand, is a much like aspirational promise, I guess.
Mm-hmm.
The initial funding and the
Mm-hmm.
initial kind of cycles of funding was coming for the promise that we can achieve the general purposeness
Yep.
of a humanoid,
Yep.
showing the humanoid form factor, and primarily kind of like leveraging the humanoid's ability to walk around and only walk.
Mm-hmm.
Like no one was talking about stairs. No one was
Mm-hmm.
talking about, for example, like curbs or all this like, things that are not, surfaces that are not flat, let's say,
Yep.
like on
Yep.
the curbs, like, or like for just, for like around the house. And like a motion in general, like at the field of research, been going for, I don't know, 10 years now. Like the
Mm-hmm.
first DARPA project back in days was basically like on locomotion. So the field of research in locomotion was like,
Mm-hmm. Mm-hmm.
much more developed. And so when you think about like funding for general purpose humanoid robot, there is this kind of like this misconception that, we assume that they will be like truly general purpose in their manipulation capabilities,
Yes.
which is kind of like they will achieve this, like human level dexterity,
Yeah.
while the tech and they will kind of like where research is and like all the demonstrations are, it's mainly kind of like whole body kind of articulation and primarily locomotion.
Yeah. Yeah.
Only
Yeah.
now, like I think yesterday, Elon Musk was like talking about hands like at length for kind of humanoid for Optimus project.
Yeah, I'm starting to see some things from Figure where they've got a robot that's walking over uneven surfaces, off-road, sort of through garbage and stuff like that. And so we're starting to see that sort of thing. And I'm
But that's
starting to
again,
see
that's
some.
like locomotion and navigation challenges,
Exactly,
right?
exactly. And I'm starting to see some that are like grabbing something out of a fridge or a drawer, but it's just beginning. And so hands are crazy hard and they are super, like if we want a robotic chef, whether or not that's attached to a
Oh
humanoid,
man.
we need great manipulation, right? To get the knife, cut the tomato without smushing it, right? The avocado, the whatever, different types of cutting of meats, for instance, versus vegetables.
Let's like spend here like a minute because like manipulation or dexterity, right? It's essentially kind of like you can visually split this like into big kind of like two big kind of buckets. Like one is like
Mm-hmm.
grasping abilities, and the second is like actual kind of manipulation.
Yeah.
So when you like take out something out of the fridge, it is like you manipulating the object, or you just like grasping and like and putting it like on a desk or like on the
Yes.
kitchen table.
Yes.
When you are cutting, let's say like you're chopping onions, are you manipulating the knife? And then there's sort of like use of tools then with everything that needs to be achieved on the use of tools side, kind of like what I was trying to tell you, like with like tip of
Mm-hmm.
the
Mm-hmm.
screwdriver. So even like manipulation right now, like the frontier, like we only starting to get to the kind of like solving like the entire grasping taxonomy. And there is like this relatively famous paper in like the circles of researchers who do dexterity research out of like 1986 or which is basically like structure the whole kind of grasping space by
Mm-hmm.
types of grasping, because like you can do like power grasp. Let's
Mm-hmm.
say like I'm holding like this cup like this or this glass
Mm-hmm.
like this, or I can do like a very like I can do like a grasp like this, right?
Yep.
Like this is two different grasps, which would
Mm-hmm.
require two different motions in your finger joints, two
Mm-hmm.
different like different muscles to be engaged. Like the trend with like humanoids right now, like and what figure is showing, especially the most recent one, placing the plates and glasses and cups in a dishwasher. This is the cuttiest stage in my view, and this is like
Mm-hmm.
like some of the hardest tasks that humanoids can do right now, especially like humanoid
Mm-hmm.
hands can do right now.
Mm-hmm. Mm-hmm.
There is another like, and the way how I think figure is presenting this, and obviously we don't know how much cuts they've done, like and like how much damage they've done. Like obviously we see on the like the kind of the most kind of cleanest and polished video, but the claim there is that like it was done autonomously.
Yeah. Yeah.
So it was not like pre-recorded trajectories of a robot. It
Yeah.
was not.
Including folding clothes, if I recall.
Yeah. So I think Figure is working on this like internal project called Helix, which is kind of AI for like full humanoid
Mm-hmm.
articulation and manipulation. So again, we don't know how much of this is like because like some of the videos that you can see online, the robotic system is actually teleoperated, especially on the
Mm-hmm.
manipulation
Mm-hmm.
side,
Mm-hmm.
while the kind of locomotion is more autonomous.
Mm-hmm. Mm-hmm.
So if you remember this like big Tesla event with Optimus Tesla Optimus
Yes, I do.
like serving drinks. So
Yeah. Yeah.
I think later they admitted that all
Yes,
of
they
the
did.
robotic systems were teleoperated, which is a great way to capture data, which is like a step one to get to the to train AI models. But I think we generally need to understand that whenever we see like a system like something shiny and bright like on internet, like we have to take it with a grain of salt.
What breakthroughs do we need to get great hands?
I actually think that like all across the stack, from like actuators, probably like even magnets. So think about like the complexity. Like human hand, right? We have muscles that articulate fingers. They actually here,
Yep.
right, in our forearm. So besides the muscles, which is like our like actuation system, we have sense of touch, which is like not just like sense of touch, it's like actually four different sensors. Like one is for vibration, one is for pressure. So our fingers can
Yep.
measure both the direct force and shear force. That's
Yep.
how we detect slippage, right?
Yep.
And we have like a feedback loop, like through nervous system.
Mm-hmm.
Basically, like if we have slippage, it kind of like sends a signal that like we have probably like to adjust
Grab
our grip.
harder. Yeah.
Yeah. And we also have like proprioception, meaning that like without our eyesight, we can touch our tip of the nose.
Yep.
Um, so
And temperature.
yeah, it's probably less relevant, like in
Mm-hmm.
pain, like it's probably less relevant for robotics. Temperature, I don't know. But the key thing is like, for utility perspective, like just think about like, like for example, chopping onions. Like you don't really need temperature for that, right? And so not to overcomplicate already complicated system. So And there are different things like what needs to be done like on the robotic hand. So one is actuation, and this is like an ongoing field of research and exploration among like mechanical engineers primarily. Like how you do this? Like,
Yeah.
are you trying to recreate the human actuation system, which is basically like almost like a tendon driven, where you have like like the power system here and then tendons running like for every joint. But then the enormous complexity there is that how would you how would you solve the wrist?
Turn. Yeah.
So, for example, like how would you solve when when you have like this 3 degree of freedom wrist, and then like every joint? This is
This is high level
complex.
engineering.
Yeah, this is very hard. And then how would you solve, as we discussed kind of like in the beginning, this whole spectrum of like being fine grained and super precise, but also like the same hardware to be like extremely powerful to withstand the, for example, robotic hands that are super fine grained, they cannot clap because they cannot withstand the kind of
The
the
pressure.
stress from the
Yeah.
stress and the forces from clapping.
Yeah.
So all of this kind of hardware systems, like everything we know about hardware right now, needs to be almost like to re-engineer to be able to fit into the into the hand that is covering relatively large dynamic range or spectrum of like of things that needs to be performed compared to a human hand, but also be packed into a kind of this kind of form factor, right? You
Yeah.
also don't want the kind of forearm to be like a 12-inch kind of pipe or whatever, because like it basically doesn't make a practical system. It makes like the whole kind of humanoid like heavier, so application around the house are less
Yeah.
feasible then. Then sensors. So sense of touch is the kind of almost like the thing that you fall back to or you look into for fine-grained manipulation, because perception is not enough. Like, you cannot solve occlusions. You can guess with your system how to solve occlusions. And like, imagine like you have like, a sink full of dishes and like, cups and glasses and like all of the stuff after, like a good dinner. So perception system just won't be able to kind of figure it out like what's there, especially what's kind of hidden like underneath. And this is like most common use case when you can like load everything from the
Yes.
sink to a
Do the
dishwasher.
dishes. Exactly. Okay. So you're talking washing dishes, can't see under the water.
Yeah. So and then like just staying to like on this example, like dishes are wet, dishes are greasy. Like perception system has no clue of that at all. So if it doesn't have a clue, it won't be able to estimate the force. It will be like
Yeah.
applying like a standard force for a plate, but the plate is greasy and it will just like slip in away. So after, let's say like, reliability of perception system is 90%, meaning that 1 out of 10 dishes will be broken. So by, you know, how many dishes you will be left with after a week?
Yeah. Not many.
Probably like zero, right? So it's like, and like tactile sensing is just the variability of things that I've seen. Like how you can build a like tactile sensing is just enormous, and the industry in general hasn't converged on like like this is like with RGB cameras we kind of converged on that technology, we use it everywhere. Like with tactile, there were like piezoelectric, magnetic, like FSRs, like capacitive. Like it's the and like some of them are, every system has like pros and cons. Some of them don't measure shear force. You need to figure out shear force either through, if you have like many fingers, like through some combination of reading from the actuator and the kind of tactile. And this is just hardware. So mechanical sensing, this is like in its infancy. And then when you go kind of like, on the software side, AI is not even being explored. Like this is like just, I mean, it's probably like a bit of an overstatement here, but like when I think about amounts of data we need to collect to build AI for dexterous systems, but also integrate all of these new sensor modalities. This is like in research, it's like
It's a
I
lot.
mean,
It's a
it's
lot, no doubt about it.
it's like you have like five or six things that gonna need to come together at the proper amount, like with proper funding, like at the right time to be able to start kind of like showing like some valid results.
So you're painting a very dismal picture right now. There's multiple technologies that we need to invent. There's multiple things we need to learn in terms of AI and control and understanding of the world and everything like that. It sounds like an impossible task.
Well, unless it is not.
Yes, everything's impossible till it's
Exactly.
possible.
Coming back to kind of our like point in the beginning that manipulation touches upon like 50% of the global economy. So think about this,
Mhm.
right? Like manufacturing, like probably like every single physical item that we import here, let's say like out of China, is
That
being
still
produced by
happens. The
hand.
US is still importing.
Looks like. Yeah, but like every single, like think about like everything we manufacture, like one way or another, is touching like human hands. So human hands are
Yeah,
producing that,
yeah.
right?
I think the key is how good do they need to be? And I think that's very dependent on different tasks. And so we have a lot of things that are going on in warehouses or in factories and stuff like that. Warehouses are a pretty simple case actually for hands. A lot of things are in boxes. If they're not, they're in packages by the time they get there, right? So you can grip, you can lift under, you can suction. There's a lot of different things, and you don't need all of this for that. And then I
But
guess there's another level of things that if you're in a factory or production scenario, I mean, what are you specifically using that robot for? There's many things that don't need all the variations of power and sensitivity that the human hands have. That's
yeah,
probably also true for a humanoid robot in a home. That's probably also true. Like for vacuuming, how sensitive does the robot need to be? For other things? We can't get from 0 to 100, right? But can we get to 20? Can we get to 30? And what does that enable? And if we get value from that, does that fund additional research to make it even better over time?
I mean, I'm more on the side of like building like general purpose systems,
Yes.
both kind of hardware and software and AI. I think what you kind of alluding to, that's been like the approach, that's like ongoing approach, right? Like to build like a
Hmm.
robotic system X for a problem Y. And it comes with trade-offs. Because for example, like, you
It comes with trade-offs, but it also comes with immediate payoffs, right? That's the Aptronic approach, right? Really super ruthlessly practical, right? What are we going to build? What's it going to work? How's it going to be used? How can we get to value quickly? And you could argue that's kind of a great way to do a startup. That's kind of an MVP type of thing, right? Versus like a moonshot or a university project to make the best possible thing ever.
that's true. Yeah. There are different approaches, right? For example, like OpenAI started like as like almost like a general purpose like system. It's
Yes.
like moonshot, and
Still pretty
obviously,
general.
yeah, because like that's basically their goal from the beginning. And now they just like once they can like achieve this like general purpose technology, they are thinking about like building this kind of like products on top of it. But I want to kind of come back to like warehouse example that and this is kind of counter to what you suggested. So even like think about the warehouses. You mentioned boxes and you mentioned different packages. So you can't use like really suction for boxes. Like suction
People
would
are using
work.
it right now, aren't they? I mean,
Well,
some people are definitely using that. Certainly, if you know the weight.
yeah. Oh, it's contingent on a specific weight. So if your system, if your box is like above the threshold, then like suction just won't work. And then like you
Mhm.
need like a technician to come there. Like and boxes, for example, it's like
Or hybrid teams. You have hybrid
exactly.
teams of
Yeah.
humanoids or robots, I should say, in that scenario. Most warehouse robots are just robots. They're not humanoids these days, although we're working on that. But you could have a hybrid human team
Yeah.
with the robots.
So it's a question of reliability then, like, and there is this metric going on that how many interventions per hour you need.
Mm-hmm. Mm-hmm.
So how basically what's the kind of reliability of
Yeah.
of a robotic
Or your
system?
warehouse management system knows what the robot is capable of and knows what humans are capable of and dynamically allocates workloads and tasks based on that information as well.
Yeah, it's kind of like again question of a trade-off, right? Either you
Yep.
build like a general purpose, like end-effector that can handle, like envelopes, like bags,
Mm-hmm.
boxes of different sizes. And
Mm-hmm.
keep in mind that like boxes of different sizes, meaning that we would need bimanual dexterity, not just like
Yep. Yep.
like one-hand dexterity.
And a lot of people are using grippers for that or different things. It's very
Yeah.
far from a hand, but it actually
So
works for
a good
certain
example
defined purposes.
is the company called Agility, which
Mm-hmm.
is just like they can like have like only this kind
Yep.
of grippers,
Exactly.
and they are like specifically targeting like warehouses
Yep.
and kind of like bimanual sort of like dexterity for grasping of like bulk objects. But then
Mm-hmm.
you kind of like need to figure it out like the balance of the body, given that you have
Mm-hmm.
this like extra load and like, things like
Yep.
that. Totally true.
And a lot of those robots, of course, are they have weight down really low, and their batteries and motors are down really low, and then they have that stability there. So there's a lot of challenges, but I guess I'd argue that almost every startup, and frankly every startup, is a trade-off, right? Nobody gets to Saturn on the first shot. First, they take a little hop, right? And so I guess the question is where there's value. You invest in startups and actually do some pretty risky investing because you do seed stage and very early stage investing in hardware, which is crazy in some sense, right? Because hardware can be expensive, it's very risky. What are you seeing as key startups in this space of gripping and grasping?
Yeah, so we do frontier investments. That's my focus. Number one, frontier robotics, and specifically frontier kind of hands. All across the stack from like actuators. Like I've been spending a lot of time like in tactile sensing, like
Mm-hmm.
thinking about like what we generally see a lot of innovation in kind of hands domain,
Mm-hmm.
especially kind of like general purpose hands.
Mm-hmm.
And I think the promise of the size of the opportunity, like if hands are solved, that can
Yes, that's
change
huge. Yeah.
the entire economics. Like think about like this, that one of the like pillars for GDP calculation is productivity. But now like productivity is becoming like endless. There is no limit to productivity. Like you can stack factories,
Mm-hmm.
like you're not bound by anything. Like you can do, like if you
Laws
solve
of
general
physics still
purpose.
apply, but I understand what you're getting at.
Yeah. No, I mean, like I'm obviously like a bit, I have like, I think investors generally should be a bit optimistic
Yes. Yes.
um, about the future. But like, if hands are solved, like, you know, think about like the base on the moon.
Mm-hmm.
Like,
Mm-hmm.
who's gonna build it?
Mm-hmm.
Like,
Mm-hmm.
what are the risks of that? But like, what if
Yep.
we have like general purpose hands? And now
Yep.
think about like everything that, like outside of our planet,
Mm-hmm.
right? If we able to kind of solve autonomous dexterity, let's put it this way, like this, like it's gonna be like. I mean, I don't want like to sound like too,
It's a
AGI
massive
is
unlock.
here,
No, you can totally,
but
if
like
it's a massive unlock, it solves a lot of different things for building a lot of things, moving a lot of things, manipulating a lot of things, helping us with a ton of things. Absolutely. My personal belief is that we won't solve hands for decades in terms of this.
I
This is
hope
crazy complexity. This is
I
amazing.
understand.
This is incredible. But I think we can get good enough to do some amazing, wonderful things. And you will have, you know what? You're probably going to have, I know certain robots, Aptronic for sure, they're building with the intention that you can swap out different hands. And that's probably an okay thing to do at some point because let's say you've got a relatively humanoid, semi-humanoid robot, maybe not even humanoid in healthcare, and it's helping with old people, maybe helping them get out of bed, other thing. That's a certain thing that it needs to do. And maybe if it's also cleaning the floors at night, that's a different thing, right? And I'm
Yeah,
okay with it having some different hands. It's not the best solution. It's not the most elegant solution, but it's a solution that can work in the real
yeah,
world today.
yeah. No, 100%. I mean, like swapping like end effectors, like is a feasible idea.
Mm-hmm.
That for example, your hand might not need to, learn how to use a screwdriver like with a hand, but like just swap like a screwdriver end effector.
As the
That's
hand, exactly. Yeah.
yeah, that's one of the fields, that like is
And that's a
undergoing
wonderful
like
thing too. You buy the robot that you need and you can upgrade as you go, right?
yeah.
Yeah. Cool. Interesting. Um, maybe you were talking about the unlock and then I kind of interrupted you, but give us the give us the moonshot to kind of close off this segment. Give us the moonshot of we solve hands, maybe never exactly like this, but maybe 90%, maybe 70%, whatever. What does that do? What does that do? What does that unlock?
Massive productivity gains, and I think that will be on par with our literally our ability to go off planet.
Interesting. Very, very good. Thank you so much, Mike, for this time.
Thank you, John.